Now can you see?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
We have cylinder, cone, sphere, and hemisphere.
In our everyday lives, examples of cubical objects include a dice, an ice cube, and a box. Solid objects, which are made up of plane square regions, are called cubes. Similarly, some examples of cuboidal objects include a book and a juice carton. The shapes of these objects lead us to the conclusion that solid objects, which are made up of rectangular plane regions, are called cuboids. We already know that plane figures are two-dimensional. Let's perform an activity to see what happens when plane figures are stacked together. Consider a sheet of paper. Now, form a vertical pile by stacking sheets of paper with the same dimensions. What type of solid is formed? We observe that a three-dimensional figure called a cuboid is formed. This solid figure has a length, a breadth, and a height. A cuboid has three parts: a face, an edge, and a vertex. The rectangular plane region of a cuboid is called a face. Here, ABCH, BCDG, GDEF, EFAH, ABGF, and EHCD are faces of the cuboid. The adjacent edges of a cuboid intersect at a point which is called a vertex. Here, A, B, C, D, E, F, G, and H are vertices of the cuboid. The adjacent faces of a cuboid intersect each other in a line segment called an edge. Here, AB, BC, CD, DE, EF, FA, AH, CH, BG, GD, FG, and EH are edges of the cube.
Do you know the Euler's formula connecting faces, vertex, and edges?
Yes, ma'am.
What is that formula?
Yes, ma'am.
A plus V equal to V plus 2.
Yes.
Let's perform an activity to understand the concept of the lateral surface area and total surface area of a cuboid. Consider a cuboidal box with no top and no base. It is made up of four faces, which are plane rectangular regions. Using the formula for the area of a rectangle, we get the area of one pair of the opposite faces of the box as L into H, and that of the other pair as B into H. Observe that the two opposite faces have equal areas. To obtain the lateral surface area, we add the areas of both pairs of opposite faces, which is equal to twice the sum of L into H and B into H. Now, consider a closed cuboidal box. It is made up of six faces, which are plane rectangular regions. Using the formula for the area of a rectangle, we get the area of one pair of opposite faces as B into H, of the second pair as L into H, and of the third pair as L into B. Now, to obtain the total surface area, we add the areas of all the three pairs of opposite faces, which is equal to twice the sum of L into H, B into H, and L into B. Let's perform an activity to find out the volume of a cuboid. Consider a vessel with length L, width B, and height H. Pour any liquid into it. What do you observe? The liquid first covers the base and then rises. Hence, the volume of the cuboid, which is equal to the volume of liquid that can be poured into it, is equal to area of the base into height. The area of the base is L multiplied by B. Therefore, the volume of a cuboid is equal to the product of L, B, and H. If L is the length, B is the breadth, and h is the height of a cuboid, then the lateral surface area of the cuboid is 2h into L plus B, and total surface area of the cuboid is twice the sum of LB, BH and LH. Surface area is measured in square units. The volume of the cuboid is the product of L, B and H. Volume is measured in cubic units. Now, consider some examples related to the area and volume of cuboids.
What is the answer? LSA of cuboid and volume of cuboid.
LSA of cuboid is 2 LB plus
4 centimeter cube.
How much you got? Volume?
144
volume is
centimeter
equal to
cube.
140. Yes.
Find out the lateral surface area and volume of a cuboid 12 centimeters long, 4 centimeters wide, and 3 centimeters high. It is given that L is equal to 12 centimeters, B is equal to 4 centimeters, and H is equal to 3 centimeters. We know that the lateral surface area of a cuboid is 2H into L plus B. Substituting the values of L, B, and H in the
Did you
formula,
get 96?
we get the lateral surface area as 96 square centimeters. The volume of a cuboid
ma'am.
is the product of L, B,
Correct.
and H. Substituting the values of L, B, and H in the formula, we get the volume as 144 cubic centimeters. Consider another example. The length, breadth, and height of a cuboid are in the ratio 6:4:5. If the total surface area of the cuboid is 2,368 square centimeters, find out its dimension.
Do this.
Ma'am, 96 centimeter, 64 centimeter and 80 centimeter.
80, 96, 80, 64 centimeter.
I am still doing. So,
Let the length be 6x, the breadth be 4x, and the height be 5x. We know that the total surface area of a cuboid is twice the sum of LB, BH, and LH. Substituting the values of L, B, and H in the formula and simplifying, we get the value of x as 4. Hence, the length is equal to 24 centimeters, the breadth is equal to 16 centimeters, and the height is equal to 20 centimeters.
is this what you got?
Consider another example. The length, breadth, and height of a cuboid are in the ratio 6 is substituting the values of L, B, and H in the formula and simplifying,
Did you
we
get
get the
this?
value of x as 4. Hence, the length is equal to 24 centimeters, the breadth is equal to 16 centimeters, and the height is equal to 20
Yeah.
centimeters.
No,
You
ma'am.
gave me some other answer, no? You gave me some 96 something.
Yes, ma'am.
2 into 74 squared is 23868. So x squared is 2368 divided by 2 into 74. Correct?
Ma'am.
Yes, ma'am.
So here,
Consider another example. Substituting the values of L, B, and H in the formula and
Yeah, this is correct. What is your answer? What answer did you get? Same answer? Hello?
Yes,
Hello?
ma'am.
Yes,
Same
ma'am.
answer. Ah, okay then.
Yes, ma'am.
Ah.
a room of height 5 meters has one door with dimensions 1 meter by 2 meters. The cost of papering the 4 walls of the room at 70 paise per square meter is 157 rupees and 50 paise. Find out the length and breadth of the room if they are in the range.
So L is to B is 4 is to 1. So 4x and 1x. Height is 5 meters. Door is 1 meter by 2 meters. So what is the area of 4 walls? 2h into L plus B. So 2 into 5 into 4x plus 1x. But we have to subtract the door. 1 into 2. $50x minus 2 multiplied by 70 paisa, 0.7 equal to 157.5. How much you got? Four walls. What formula did you take?
2 bracket BH plus HL.
2h into L plus B, right?
Yes, ma'am.
That is the area of the 4 walls. That is, and minus the door. We are not papering the door. Correct?
Ma'am.
The door is has dimensions 1 meter by 2 meters. So 1 into 2. And that whole thing multiplied by 0.7 equal to 157.5. How much you got X value?
Ma'am, 4.54.
4.54 you got.
4.46, ma'am.
4.6 you got. I got
4.4.
I got 4.9.
Ma'am, I got
ratio
4.46.
Let us see.
4:1. Let the length of the room be 4x and the breadth be x. The area of the 4 walls excluding the door is equal to the area of the 4 walls minus the area of the door. Now, the area of the 4 walls is equal to 2h into L plus B, and the area of the door is equal to L into B. Substituting the values of L, B, and H, we get the area of the 4 walls excluding the door as 50x minus 2 square meters. A room of height 5 meters has one door. Therefore, the cost of papering the 4 walls at the rate of 70 paise per square meter is 35x minus 1.4. This implies that 35x is equal to 158.90. Simplifying, we get the value of x as 4.54. Hence, the length of the cuboid is 18.2 meters and the breadth is 4.54 meters.
Did you get this answer?
Yes, ma'am.
157 point.
Yes, ma'am.
Okay.
Let's perform an activity to understand the concept of the lateral surface area and surface area of a cube. Consider a cubical box with no top and no base. Let the edge of the cube be A. Observe that the cube is made up of 4 square faces. Using the formula for the area of a square, we get the area of each face equal to A square. Lateral surface area is the sum of the areas of all the 4 faces, which is equal to 4A square. Now, consider a closed cubical box. Here, the cube is made up of 6 square faces. The area of each face is equal to A square. Now, the total surface area is the sum of the areas of all the 6 faces, which is equal to 6A square. Let's perform an activity to find out the volume of a cube. Consider a vessel with length, width, and height, each equal to L. Pour any liquid into it. What do you observe? The liquid covers the base first and then rises. Hence, the volume of the cube, which is equal to the volume of the liquid that can be poured into it, is equal to area of the base into height. The area of the square base is L multiplied by L. Therefore, the volume of a cube is equal to L cube.
Sometimes they call it, they name it as A cube also.
If L is the side of a cube, then the lateral surface area of the cube is 4L square and the total surface area is 6L square. Surface area is measured in square units. The volume of the cube is L. Volume is measured in cubic units. Now consider some examples related to the area and volume of cubes. The volume of a cube is 1000 cubic centimeters.
So what is the side?
10, ma'am.
10, ma'am.
600 centimeters square, ma'am. Total surface area.
6A squared.
Find out
Yes, ma'am.
its total surface area. Let the length of each side of the cube be L centimeters. We know that the volume of a cube is L cube. Substituting the value in the formula and solving, we get the value of L as 10 centimeters. But the total surface area of a cube is 6L square. Substituting the value of L as 10 centimeters, we get the total surface area equal to 600 square centimeters. The perimeter of
Find
one
out.
face of a cube is 28 centimeters. Find out the total and lateral surface areas of the cube.
What is your answer? What is A? Edge of the cube?
Ma'am, 7.
7, ma'am.
Ma'am, 7.
Then total and LSA and TSA. 6A squared, 4A squared.
Total surface area is 343.
Ma'am, 6, ma'am.
343 and then 343 you got.
Ma'am, 294 centimeters.
Ma'am, 294 centimeter cube.
294 and
Base of a cube
other one
is square in shape.
4A
Therefore,
squared.
the perimeter is equal to 4 into the edge of the cube.
196, ma'am.
Substituting the
196.
value of the
196,
perimeter
ma'am.
as 28 centimeters, we get the edge of the cube as 7 centimeters. Now, the total surface area of a cube is 6L square. Substituting the value of the edge as 7 centimeters, we get the total surface area equal to 294 square centimeters. The lateral surface area of a cube is 4L square. Substituting the value of the edge as 7 centimeters, we get the lateral surface area equal to 196 square centimeters.
Correct? Yes?
Ma'am.
3 cubes.
Do this surface area of the cuboid.
Ma'am, 1024 centimeters square.
1000.
1024.
Let's check.
Each of side 8 centimeters are joined side by side. Find out the surface area of the resulting cuboid. For the resulting cuboid, the length is equal to 3 times the edge of one cube, which becomes 24 centimeters, and the breadth and height are equal to the edge of the cube, that is 8 centimeters. We know that the surface area of the resulting cuboid is twice the sum of LB, BH and LH. Substitute the values of L, B and H in the formula. The surface area of the cuboid is equal to 896 square centimeters.
How did you get 2000? How?
And we get 1024.
How? 1020. How?
Ma'am, 6a square plus 6a square plus 6a square. ma'am.
No. When the cubes are
Ma'am,
joined,
subtracting that area of that middle two faces.
no, don't do like that. See, the cubes are joined, so the length will become 8 plus 8 plus 8. Height and breadth will remain the same. You can't do like that. If you take
Okay, ma'am.
3 cubes and join them, you will get one cuboid, no?
Yes,
What are you
ma'am.
subtracting?
And we
What
can
are-
subtract that middle two faces, that area of middle two.
Then you subtract and check whether you will get 896.
No, ma'am.
No,
No, ma'am,
you won't-
1020.
you won't get. So it is joined. So length will become more, breadth and height will remain the same. Cube will become cuboid.
Now try these questions and check their answers on the next page.
Take this as homework.
Yes,
Take a
ma'am.
screenshot. Okay. Can we go to the next part?
Yes, ma'am.
Ma'am.
Here are the answers for the questions given on the previous.
In our everyday lives, examples of cylindrical objects include a chimney, an iron pipe, a circular pillar, and a gas cylinder. Such objects have curved surfaces with circular ends and are called circular cylinders. If we take a number of circular discs and stack them up, what kind of an object would we get? If the discs are not stacked vertically, a circular cylinder of radius r is formed. Now, if the discs are stacked vertically, a right circular cylinder is formed. Hence, it can be concluded that if the discs act at right angles to the base, then a right circular cylinder is formed. Otherwise, a circular cylinder is formed. In this topic, we will concentrate on solving problems on right circular cylinders.
So only right circular cylinders are considered. The other type is not considered.
The solid obtained by revolving a rectangle about one side is called a right circular cylinder. The two plane ends that are circular in shape and parallel to each other are called the bases of a cylinder. The length of the axis of a cylinder is its height. The radius of the base of a cylinder is known as the cylinder's radius.
What is that revolving a rectangle? What is that? Revolving a rectangle. What is it? Supposing you take one rectangle like this, okay, and then revolve it like this, fully, at a speed, okay, you will get one cylinder. If you revolve it with great force, that is the meaning. Can you see my screen?
Yes, ma'am.
Yes, ma'am.
Let's perform an activity to find out the volume of a right circular cylinder. Observe that when we pour a liquid into a cylindrical jar, it first covers the base and then rises. Thus, the volume of a cylinder is given by the area of its base multiplied by its height. So, the volume of a cylinder is equal to pi r square h. Let's perform an activity to find out the curved surface area of a right circular cylinder. Observe that a cylinder can be obtained by folding a rectangular sheet of paper. Here, a cylinder has been obtained by folding a rectangular sheet of length L and breadth B. The length L becomes the height of the cylinder. The breadth of the rectangle is equal to the perimeter or circumference of the base of the cylinder. If the radius of the circular base is r, then its circumference is 2 pi r. Now we know that the length of the rectangle is equal to h and its breadth is equal to 2 pi r. The area of the rectangle is the product of its length and breadth, which is equal to h multiplied by 2 pi r. Therefore, the curved surface area of the cylinder is equal to the area of the rectangle, which is equal to 2 pi r h. Let's perform an activity to find out the total surface area of the right circular cylinder. Consider a closed circular cylinder. To determine the total surface area of the cylinder, find out the sum of the curved surface area and the areas of the top and base of the cylinder. You will find that the total surface area of the cylinder is equal to 2 pi r multiplied by h plus r.
Got it?
Yes, ma'am.
Yes, ma'am.
Here are some formulae related to a solid right circular cylinder and a hollow right circular cylinder. Let us consider some illustrative examples. Find out the curved surface area and the total surface area of a cylinder of height 30 centimeters and base radius 40.
Do this.
Two 2,640
TXA?
TSA, ma'am.
Correct. You add
2,640, ma'am.
2 pi r squared, you will get it.
3870.
3870.
72, ma'am.
22. Okay.
14 centimeters. Here, the radius of the cylinder is equal to 14 centimeters and its height is equal to 30 centimeters. We know that the curved surface area of a cylinder is 2 pi r h.
2640.
On
correct.
substituting the values of pi, r and h in the formula, we get the solution as 2,640 square centimeters. The total surface area of a cylinder is equal to 2 pi r multiplied by h plus r. On substitution, we get the total surface area equal to 3,872 square centimeters.
Is this what you got?
Yes, ma'am.
Yes, ma'am.
2 pi r into r plus h.
A vessel is in the shape of a right circular cylinder. Its volume is 448 pi cubic centimeters and its height is 7 centimeters. Find out the radius of
Do this.
Ma'am, 8.
8, huh?
its base. We know that the volume of a cylinder is equal to pi r square h. On substitution, we get 448 equal to 7r square. On solving further, we get the base radius of the vessel as 8 centimeters.
Correct.
The volume and curved surface of a cylinder are 1650 cubic centimeters and 660 square centimeters respectively. Find out the radius and height of the cylinder.
Do this. Got it? What is the radius?
Ma'am, 5.
Correct. Height? Pi r h equal to 330. R you know, pi you know, h you find out.
Ma'am, 21.
21 you got? Yeah.
We know that the volume of a cylinder is pi r square h. This is given as 1650. The curved surface area of a cylinder is 2 pi r h, which is given as 660. Therefore, on dividing the volume of the cylinder by its curved surface area, we get the value of pi r equal to 5 centimeters.
Pi r equal to 5.
The volume and curved surface of a cylinder are 1000, but pi r square h is also equal to 1650. On substituting the values of pi and r in the above equation, we get h equal to 21 centimeters.
Correct.
Hence, the radius of the cylinder is equal to 5 centimeters and the height of the cylinder is equal to 21 centimeters. The length of a hollow cylindrical pipe is 21 decimeters. Its outer and inner diameters are 10 centimeters and 6 centimeters respectively. Find out the volume of copper used to make the pipe.
Outer,
height-
outer volume minus inner volume.
Ma'am, what is the 21 dm, ma'am?
dm is decimeter. So here you have to multiply the length by 10 because 10 decimeter is 1 centimeter. So you will get, no, I'm sorry, 1 decimeter is 10 centimeter. So multiply the decimeter by 10 centimeter to convert to centimeter. 1 decimeter is 10 centimeter.
1056 centimeter cube, ma'am.
1060. Okay. So pi r squared h minus pi r squared h. How much you got?
1056 centimeter cube, ma'am.
Okay, let's check.
Height of the cylindrical pipe is 200 centimeters, and the outer and inner radius is 5 and 3 centimeters respectively. We also know that the volume of copper used to make the pipe is equal to the volume of the external cylinder minus the volume of the internal cylinder. This means that the volume of copper is equal to pi h multiplied by capital R square minus small r square. On substituting the values of pi, h and r, we get the volume of copper equal to 10,560 cubic centimeters.
So you can just use YH into R squared minus R squared.
The diameter of a circular well is 4.5 meters and the depth of the well is 14 meters. Find out the cost of cementing the inner curved surface of the well at 2 rupees 50 paise.
Do this. Diameter is 4.5. Radius is 4.5 by 2. Depth is 14. That is, height is 14. So here, what should we find? CSA. CSA of cylinder, 2 pi RH multiplied by 2.50.
495 rupees.
495. 495 rupees. Let us check.
Per square meter. The radius of the well is 4.5 divided by 2 meters and its height is 14 meters. The inner curved surface area of the well is equal to 2 pi RH. On substituting the values of pi, r and h, we get 198 square meters. The cost of cementing 1 square meter is equal to 2 rupees 50 paise. Therefore, the cost of cementing 198 square meters is 495 rupees.
Correct.